How much thermal energy does 4 moles of pure diatomic oxygen gas have at 20 degrees Celsius? So having established in the last example a formula for this, we can go ahead and use that formula for a diatomic gas. The total thermal energy is equal to 5 halves nRT. So thermodynamics is pretty straightforward, and kinetic theory of gases can be pretty straightforward as long as you use the right tool for the right job and make sure that you get all the details right. And that's one of the things that we're looking at here, because there are a lot of little pitfalls. And one of them that constantly comes up is, like, I could go in here and say, okay, clearly N is equal to 4, right? And maybe I'll write that as 4 and put mole for the unit. R is equal to 8.314 joules per Kelvin mole. And then a pitfall that I'd like to prevent is if you put in 20 for the temperature, but really this should be in Kelvin, 293.15, if you add the 273.15 to the 20 degrees Celsius to get the correct temperature in Kelvin. So that's an easy pitfall to do with this. So that's, there are just these details we want to get right. Once we're there, we can kind of look at the units, and we're expecting an energy, so I think it makes sense that the moles cancel, kelvins cancel, and joules is what's going to be the unit in the final answer here. And consulting my calculator gives a result for this calculation of 24,372.491, but maybe I can just state that as, since this is kind of like a 2 sig fix for the 20 degrees Celsius there, maybe that's just 24,000 joules, and that's okay to write that way. Let's go ahead and check the answer, and it says 24 kilojoules, which is equivalent to 24,000 joules, and maybe a little more comforting to look at that way in regard to the rounding.